Well, welcome to this session on the regulatory environment. Delighted to see all of you. We will have a panel discussion, and then we will be taking questions from the audience. So if you would just go to slido.com and use the PASAM code, or just take a picture of the QR code, that will get you there first. Two, so to start off with, we have an esteemed panel. We have a regulator, a consultant, a couple of aircraft manufacturers. So we're going to have a broad perspective on where we are and the challenges and what needs to happen. Saskia, if you could introduce yourself, please.
Sure. So I'm Saskia Horsch. I lead regulatory and public affairs globally at Lilium. We manufacture eVTOL aircraft based out of Germany.
Good afternoon. I'm David Marcantel. I'm an expert associate partner with McKinsey. Spent about half of my career working for airlines, but most notably doing a lot of certification, air carrier certification. So I'll be talking a little bit about the business and certification aspects of trying to actually put these aircraft into service.
Good afternoon, everyone. My name is Kyle Martin. I'm the Vice President of European Affairs for the General Aviation Manufacturers Association, or GAMA. So our role as GAMA is to bring together the world's leading manufacturers, some 150 members at present, across all areas of the aviation sector. But in the context of this panel, we bring together all the key players in the advanced air mobility and urban air mobility space from a manufacturing perspective to represent them towards the regulators.
Hi, everybody. My name is Tom Muniz. I'm the Chief Operating Officer of Archer Aviation. So we're an aircraft developer bringing to market the Midnight aircraft you see behind you here. So it's a pilot plus 4-passenger electric vertical takeoff and landing aircraft. We're currently certifying the vehicle with the FAA and targeting entry into service in 2025. So our business case is basically taking people who are currently spending time stuck in traffic on the ground and trying to give them a way of moving around in the air by using really efficient, sustainable, safe aircraft like what we're developing. Looking forward to it.
Hello, good afternoon. My name is Suleiman Mohimidi. I'm the Executive Vice President of the General Authority of Civil Aviation of the Kingdom of Saudi Arabia for the safety and environmental sustainability. Probably today I'm going to share our experience and efforts to enable the advanced air mobility in the kingdom as a non-OEM state. Probably it would be very beneficial for everybody. Thank you.
Great, thank you. Well, to start off, I think it's logical to think about where are we from a regulatory and certification standpoint, especially for EASA and FAA, where a lot of the vehicles are going to be manufactured. Kyle, would you like to kick us off?
Thank you very much, Leanne. So, as I said, our role as GAMA is to focus on the certification and regulatory aspects. So way back in 2015, which is 8 years ago now, we formed a committee within GAMA bringing together originally, I think, 12 companies looking at electric propulsion and advanced innovative technologies. That's what we now call our Electric Propulsion Innovation Committee, which is EPIC. So that brings together some 400 experts from all around the world, from key companies like Lilium, like Archer, and many others. So where are we at now? So if you like, on the certification side, we'd start there. So we have EASA published in 2019 their special edition for VTOL, which was discussed in one of the panels earlier today. That was published in 2019, and we've been working since then with EASA and the various OEMs to define how we're going to have vehicles that can meet the means of compliance to that, which is no small task because this is a whole new sector. The vehicles you see in this hall right now are unlike anything we've certified or have entered into commercial service before anywhere in the world. So it's quite a challenge, and there's a lot of diversity and new technologies, and no two aircraft are alike. There's different means of operation, different means of design, different numbers of propulsion systems. So really, it's a diverse spectrum, and trying to get a consistent level playing field for all the different OEMs to find compliance to those requirements is key. On the FAA side, which is also a key interest because that's maybe the largest market in the current setup, the FAA published the proposed certification requirements for Joby and Archer December, January this year for public consultation. We spent a lot of time working on those, and we're waiting on the finalization of that in the coming weeks. So there's a lot going on both sides. The challenge we have is all these vehicles, all these manufacturers, quite rightly, want to get their products to market at the right pace, at the right time. But we also have to make sure they're safe. So we have to have the regulations in place so the vehicle can be designed, tested, certified, proven to enter into service. that makes it harder somewhat to find alignment between the regulators because the European OEMs are working with EASA over in Cologne, the US manufacturers are working with FAA, and then these companies are now trying to speak to other countries where they're going to sell and operate their products. So we need to make sure we're informing them of the process. So our role as Gamma, and we had a meeting just in Cologne last week with about 30 different manufacturers, EASA, FAA all in the room, discussing exactly these things. How do we bring it together? How do we support these manufacturers to bring their products into service on time without holding up the process, but find a way for example, Archer to export to Europe or Lilium to export to the US and similar back and forward. That is our challenge at the moment. But the regulations are pretty much in place from the certification perspective. The means of compliance are now the key challenge in finalizing those with both regulators as we look towards certain OEMs already targeting certification by 2024, 2025 timeframe.
Yeah, and maybe just to build on that and give you a little bit of perspective from Archer. So we've been really focused on the US because obviously that's where we're based. We think there's really compelling launch markets there. But if you think about the capabilities that an aircraft like this would deliver, obviously there's really attractive markets all around the world. So absolutely we are very supportive and want to see harmonization of the regulators to get these vehicles out there. But what we've seen is essentially two different approaches. So in the US, the FAA has taken a very specific approach, treating each aircraft differently. So as Kyle mentioned, last November, they published a draft of our certification basis that's unique to our vehicle. And the reason they did that is there's no existing rule part, like Part 23 or Part 25, that has standards for a vehicle like this. I think it's likely those will exist in the future, but the FAA is essentially treating each aircraft individually until we get there. Europe's taken a slightly different approach, where they've been more prescriptive on some of the design and operation elements up front, which makes it slightly more challenging because you need to really design to those specific standards. So at Archer, we've been, again, just super focused on getting our product to market. That's kind of really a core piece of the DNA of the company. That feeds through in many different ways. So for example, when we started the company many years ago, we engaged with the regulator really early to understand what requirements we should expect in order to design to those requirements. So we think that's really paid dividends to us and are very happy with where we are in the process. So we mentioned the G1. Obviously, the next step is developing what's called the means of compliance. So these are essentially the ways that you show that you meet the high-level safety requirements. And then the next step after that is a very detailed, what's called certification plan. So this is really the phase of the process that we're in. We've been working on certification for about 3 years for our aircraft. For us, next year is all about the implementation phase. So getting the aircraft out there, flying test points for credit with the FAA, building the data we need to demonstrate the vehicle is safe. So we feel like we've got a really clear path forward. Optimistic about international markets, but we haven't yet decided what makes sense for us as a business.
And you gave me a perfect hook to continue with, with a perspective from Lilium from an EU point of view. So Lilium is an eVTOL manufacturer. We're based out of Munich, as I said earlier. We focus on regional connectivity, so we're not in the urban air mobility space, more the regional air mobility space, covering initially up to 175 kilometers. And as German-based company, we will be certified by our European regulator, EASA. You were saying that the difference to the US is that they're pretty prescriptive. I would say it's exactly the contrary, in the sense that, yes, EASA tends to, to establish standards, and they're very methodologic and, structured. But that has been a real benefit for us because since the very beginning, we knew what we would get into. And so when we look at the different streams that are relevant for regulation, the aircraft certification on one hand, and then you need operational rules so that you know how to operate the aircraft. You need rules to know how to design the landing sites so that you can actually take off and land. You need rules for pilots because we need to know how to train and qualify these pilots that will operate the aircraft. And last but not least, you also need airspace integration solutions because we will integrate not only with the drones in lower airspace levels and use space, but we will also integrate And lots of people tend to underestimate that. We integrate with the normal traffic, so with ITM, and that's quite a challenge. And so when you look at all of this, building all of these rules, we can build on the and EASA has done that on rules that exist already partly for helicopters, but also for airplanes. But of course, the eVTOL is different; it has a specific nature, so there needs to be adaptations. From a certification perspective, we've engaged quite early with EASA to basically apply for certification. That was back in 2017, and as Kyle said, they came out with the certification basis quite early. Then we came with something that is called CREA-01, which is basically our certification basis, telling us all of the requirements we need to fulfill for our aircraft. And the second step is now we're actually quite advanced in determining the requirements that are specific to our aircraft in something that is called means of compliance. And for some parts, we as Lilium have proposed our own means of compliance to accelerate the process. And I can say so from EASA's point of view, the means of compliance that are developed from their side, we've reached 72% or something progress. So the missing part is what we're working through now. We've just closed an important phase in the program, which is the PDR, the preliminary design review. Now we're moving into CDR, which is where all of this, these last requirements will be dealt with. And so we're quite confident that by 25, which is what we're aiming for, we will then get the certification. And based on what I just said, we really know, what we have to work towards. And maybe just last word on where on the milestones we have achieved, because that's quite important. That was quite important actually to progress in this whole process. Earlier this year and end of last year, we actually managed to, with our demonstrator that is flying in Spain, managed to hit very important milestones, which is the full wing transition. So the transition from hover to wing-borne flying. That was a very important milestone, and the second one is full speed flying. So we have progressed really well, and our relationship with EASA is really positive and constructive, so that we're actually quite optimistic that certification for 25 is realistic within subsequent entry into service.
We have different. Oh, go ahead. Yep.
Well, I was just going to say, both Tom and Saskia have been talking about the equipment certification, but they both alluded to the importance of designing for the operating environment that they're going to be in. The high density, the necessity to be able to accommodate drones, other aircraft in the area, in the urban environment that these aircraft are expected to be operated in. And I think an important part of that overall certification view is the readiness that's being done to prepare for that. Many of you may be aware that both Joby and Archer, and I'm not sure what they're doing in Europe, but are in the process or already have created Part 135 airlines, essentially for the purposes of a test ground for preparing for that. And while there are a lot of similarities in terms of existing air ambulance, site tour operators, et cetera, to the eVTOL or the advanced air mobility environment, there are a lot of differences. The level of complexity associated with the vertiport operations is much, much higher than we've ever experienced in historical operations. The on-demand nature of this with the level of utilization is at a much, much higher level than we've ever experienced before. So, and then of course there's the reality that the training programs, particularly for the pilots, have got to evolve both legalistically as well as from technically to reflect the aircraft and how it's flown differently. Without question, I know many of you heard some of the previous sessions and many of the CEOs talking about the ease at which these airplanes can be operated, which is entirely true. I mean, they are incredible in that respect, but they are still entering into the national aerospace system in some capacity, which requires an understanding and an adaptation to that. And so the real point of this is that while we get a lot of talk hear a lot about the necessary equipment certification efforts and all the incredible design and technology that's going into going through the significant hurdles there, don't forget that they're also at the same time these operators, these manufacturers who are also operators. It's a very, very unique ecosystem that they're creating are having to do this at the operational side as well. And so there'll be a lot of work being done in 2024 as they prepare for that, those first aircraft to come into service late 2024, 25, 26.
Well, you teed me up perfectly. The next question is pilot certification, and what's the status there?
So pilots. In the case of the U.S. and the FAA, the FAA just published, as alluded to earlier, an SFAR that addresses most of the pilot uncertainties, I guess is the best way to describe it. Although there are still, as I heard the CEO from Joby just a few minutes ago talk about how there's a few things on the fringe, such as a potential need to put a dual controls in a training aircraft. I mean, that's not something I don't think the industry was quite expecting, and it may not occur. It's part of the NPRM process, and hopefully that will be resolved. But I think one of the other things that's interesting about one of the things that I've been tracking pretty carefully is how the advanced air mobility market can actually be a contributor, a significant contributor to the future pilots that are required for large commercial airlines that are out there today. We read about it all the time about the shortage of airline pilots and how service is being reduced globally because there's not enough pilots to operate the regional aircraft through the traditional routes of flowing pilots up. And that traditional route has really been constrained by the period of roughly, in a pilot's career, from 500 hours up to 1,500 hours. And getting that 1,000 hours has been the hard part. There's just not enough flying opportunities. Most pilots do that either through instruction or flying corporate. But the problem with corporate flying, it's a great experience, but the problem with it is they don't get enough flight hours in a calendar period of time. It takes too long. In the advanced air mobility market, however, there's a chance to change some of that. Because we are operating Part 135, the requirements are the same as other corporate aviation pilots, so there's no difference in the standard of safety there. But the difference is that the utilization rate of these aircraft are far, far higher than the corporate brethren that they might exist. We're expecting, the industry's expecting that typical eVTOL aircraft or pilots are going to have as many as 900 hours per year. They're going to be pretty much capped out in terms of what their maximum flying is. You contrast that to a typical corporate pilot who's going to get about 400 hours a year. And so that reduces, I should say, the total time to get to the minimums that are required to get into the left seat of to be a pilot in command of a 121 carrier by as much as 14 months. And so it's not only is it reducing the amount of time, but it is also, very, very importantly, increasing the number of flying jobs to create that pipeline to fill that in. So if the schools can continue to expand, they can get bigger in terms of flight training, but if you don't have the flying jobs for them to go to, there's no place to fill it. It gets constrained. Well, all of a sudden, if we in McKinsey forecast that by 2030 there will be roughly 1,000 eVTOL aircraft in operation, and I realize that some of the industry feel that might be higher, but we think that number is relatively conservative. But nevertheless, at 1,000 aircraft that are flying, and we think that that's going to require about 3,200 pilots. So that's 3,200 new flying jobs, high utilization flying jobs that did not exist before. So this complements the corporate aviation environment and can represent anywhere from, depending upon your math, 15 to 25% of the annual requirement of pilots globally. So it is a significant contributor to bringing pilots into the system who would have been trained on advanced equipment, been trained in the National Aerospace System, and are ready for the right seat of a commercial airliner, the traditional path that they go. So it just kind of helps move the overall industry forward and allows us to grow safely and effectively without taking so long.
Yeah, I think it's spot on. So United is one of our big partners and customers, and a question I get a lot is, where are you going to find the pilots that you need for these? But what's kind of a misconception there is United comes to us and says, oh, this is great because you can help us get the 10,000 pilots we need for our mainline service by the end of the decade. So, for example, United stood up their own flight training school called Aviate that's located in the state of Arizona out in the U.S. And, to the conversation earlier, they can get the pilots to 250, 500 hours, but then there's this gap where there's not a great way to get the operational experience needed to get your ATP and get into service. So we're really optimistic about how this new advanced air mobility industry really helps the broader aviation industry when it comes to increasing that labor pool, increasing the amount of diversity in the pilot population, and I think it's just really great for the entire industry.
I think one of the challenges we have, because there's so many different pipelines to get pilots into the system. So you're going to have ab initio pilots starting from scratch. We need to create a pathway for them in both the European, US, and other regulatory systems. But also, how do you transition from being a commercial fixed-wing pilot into being a VTOL pilot from either, or also from a helicopter side? So that's why we're doing a lot of work. You mentioned that the SFAR was published by the FAA. We've been working with the EASA for a couple of years now on their training approach, which should be sent to the European Commission for final regulatory approval in the next few weeks. Really looking at the initial, how do you do a transferability from existing to the new type rating construct, but then also further down the line, what does it take to train an ab initio pilot on these vehicles? Because as we've heard, they're quite different to traditional aviation. It's not like a 6 steam gauge Cessna 172 that people start their training on. These are much more advanced vehicles with much more automation on board and a completely different operating environment. Like you're not taking off and doing traffic patterns. What's the replication for that on the vertiport space? You're going to be doing patterns in and out of vertiports, and how do you do that with single or dual pilot controls as part of the ongoing debate? We're also trying to see how we adapt those type ratings in both the European and US systems so there are multiple pathways to feed that pipeline to meet that very large pilot training demand that we're seeing in the coming years for these new vehicles.
So given the differences between regulations, what are the biggest challenges? What are the biggest hurdles?
Well, I think from our perspective, we see a very clear path to market. To the conversation earlier, though, it's not just the aircraft, right? There's certification around manufacturing, there's the SFAR operations, there's Part 135 in the airlines. So for us, we kind of see how all these pieces fit together, at least in the US, and we're basically heads down executing on that path. Certainly, there's a lot of work to do, but in terms of uncertainties, we feel really, I would say, stable and have a clear path forward. So.
Yeah, I will just add to that. I think we have a good path forward. I think there are 3 main challenges. One is getting basically regulatory readiness, so getting the framework that you need for all of the different areas that I described earlier up and running in time for the first vehicles entering into service. And we've got our German friends from Volocopter starting next year in Paris. So we really need to hurry up. I think here EASA has really done a fantastic job in starting really early on to craft the rules and try to be ready on time. And when I look at the discussions that we're having, for example, in the air ops field, the monthly meetings that we have, bringing together all of the industry and basically regulators from member states to make sure that the rules can be published on time. It's actually a fantastic collaboration to ensure that we have a framework that is not only ready, basically ready on time, but also with highest safety standards. Because I think we believe strongly in bringing everyone around the table and coming together and collaborate on the rules that we need to have a really high safety standards, as that is a non-negotiable. And when you have member state regulators around the table, you have industry players, you've got EASA, you've got the expertise there to really frame that. So timely regulatory readiness is one. The second one is flexibility, because one-size-fit-all prescriptive approaches, will have the risk that you foreclose for some of the technologies that we see around. As someone said already, it's so diverse. There's so many different eVTOL manufacturers, so many different technologies that we see. If you come forward with a framework that is basically, like we have in traditional aviation, one size fits all, here are the rules, just take it or leave it, you will there's a risk that you will foreclose some of these technologies. So having some sort of flexibility, and we see this with the EASA approach, and you'll think that I love my regulator. We do, but there's not everything is perfect, but in that sense, the approach is quite, it's quite positive. Is this performance-based, risk-based approach where you basically have to demonstrate that you can fulfill, you can meet the rules according to the performance of your aircraft. So this allows for different technologies to evolve. And I forgot what the third one was, but the two ones are already quite important. So these are the challenges.
Thank you.
I think the biggest risk or concern that I have actually is right as we complete the certification of the first group of aircraft, the Joby aircraft, the Archer aircraft, and then we start that transition into trying to get certified for operations. It's going to be enormous pressure to do that quickly in order to be able to really start the production lines and start moving forward from a business perspective. The challenge that exists out there is that while a lot of the OEMs have been creating this Part 135 as a testing ground and a preparation, and I'll talk more about that in a second, the reality is that even though the regulators are publishing operating rules, none of the regulators have actually certified anybody for this in this way. So the same delays and some of the shifting of direction that we saw on the equipment manufacturing side, very concerned that might happen on the operating side. Now, there's a lot of ways that we can, that I think the industry is trying to mitigate that, and that is through the simulation of operations with these 135s, with a fixed wing aircraft or helicopter aircraft operating in a highly a similar simulated environment, to be able to prove out the technologies and the approach and the management of these airlines and the management of the operations, so that they can do this effectively and be able to streamline and de-risk that. But if the regulators are not resourced or on board as you go through that process, because remember, none of them have had to do it with this, and this is now moving from a different section in the regulators from, at least within the FAA, from the certification group over to standards. And that's just a whole other group of people that have got to come up to speed and become comfortable with these vehicles. And the reality is that they will not and should not accelerate because, compromise on the safety, but it's about getting them comfortable with that. And so that's why it's so incredibly important that these simulated operations in 2024, which I think we'll hear more about, are so critical to being ready to, not just for the operator, for the manufacturers, but for the regulators to be able to go through that certification process and efficiently and effectively, be able to grant air carrier or add these aircraft to their existing certificates and allow them to actually start flying.
Yeah, probably from a different dimension, a different angle. We've heard that the so-called state of design and state of manufacture, and the OEMs already having a dilemma, an issue, finding a unified way to certify and get those aircraft safely into operation. Now, from my perspective as a regulator of a state of registry and a state of operator, we do have some challenges determining which concept to be followed, whether it's the EASA's one or the FAA, the descriptive or the performance-based. And as Tom said, that an international demand is already in place for those aircrafts. And we need to be ready when the time comes to operate. Volocopter are already doing some tests in the kingdom, partnering with NEOM as the future air mobility in NEOM City, which is the city of the future. Also, Lilium have signed with Saudi Airlines for 100 aircraft. So we are already under pressure trying to find a way for the safe integration of those technologies in a third country, in a state of registry and a state of operator. So we are engaging today with the EASA, with the FAA, also with the ICAO expert panel group to try to find our path or way forward to assure a timely certification in the kingdom and deployment of those technologies. So I think one of the challenges is international harmonization and the international collaboration to enable those technologies.
Well, have you seen any cooperation, collaboration, across agencies that is being helpful?
From our experience, we've seen a very cooperative efforts from EASA and from the FAA, also the OEMs, and the willingness to partner with GACA. Now we're running a partnership between NEOM, Volocopter, and GACA to do some part of the certification campaign in the kingdom. And we're developing the regulatory and certification specification in the kingdom. Now we're also in discussion with Joby to do the same thing with Red Sea. So we're having an international collaboration environment, but I think we need to focus more on international harmonization and collaboration with others. Thank you.
So as GAMA, as a global association, our whole message is always harmonization. But I can tell you, working on multiple different rulemaking and different harmonization efforts, harmonization takes time. And even more so in this case, because people are starting from a complete blank sheet of paper, as they were a few years ago, with a completely revolutionary new type of aircraft and operations. We're now at the point where we could force EASA, FAA, and other regulators to sit in a room for 6 months to a year and harmonize every single paragraph, but I don't think my respective members on either side of me would thank me for that effort. They need to get their products to market. We need to certify in the initial states of operation, learn from how these vehicles work and operate in service, and then adapt in the long term. Because effectively what EASA and FAA have done with their certification bases, these are special conditions. They're applicable to initial designs of aircraft. They're not codified in national laws or Part CFR from the FAA system or SCCSs from EASA. We will learn, we will develop, and then the time for harmonization will be coming up in the coming years, but we don't want to delay unnecessarily certification of the initial vehicles and delay that learning to get perfect harmonization, because perfection is the enemy of the good in this case.
But maybe to add also, again, the European perspective, there's quite a lot of cooperation and collaboration ongoing, both with the regulators, but then also between industry players. And maybe just, 2 examples. One, sort of in the context of certification, but also pilot in other areas. There's different industry standardization bodies, EUROK being one, where there's a close link also to EASA, where they would rely on EUROK, which brings together all of the industry to develop some of the rules that they, I wouldn't say lack expertise, but rely on the industry to come forward with proposals. There's other bodies as well. And then maybe something completely different, actually more going into almost R&D, but being fast-tracked, given our industry and where we're going, is an institution called CESAR, which is like a joint undertaking, which is like a collaboration at EU level, where they put out basically projects, calls for which industry can apply, and develop something which will then, can be used to basically leverage commercially. And so Lilium is quite engaged in CESAR and has just recently won 2 big projects with big consortium, uniting big players just like Honeywell, and regulators are in there, politics are in there, and the idea is to really then use this kind of tool, which is funded by the EU, to create the ecosystem, to start creating infrastructure, creating airspace integration solutions, so that we can actually then, once we go live, can utilize this commercially. And that's actually quite remarkable, how the EU institutions help and really push forward to allow this industry to come live.
That is great. So we have about 10 minutes, and I think we should try to get through about 5 of the industry questions. So let's go quick. Okay, Tom and Saskia, what are your plans for pursuing certification in the UK?
So right now we're solely focused on certifying in the US with the FAA. Like I mentioned earlier, like a core part of our DNA is keeping focus across the entire sort of effort at Archer. And ensuring that we get to market on our timelines. So entry into service in 2025. We're super optimistic about global markets. We have not announced where we intend to operate, but we're currently considering opportunities, let's say, all around the world, including the UK. So lots of interesting things to do.
Well, given that we have a partnership with a UK-based operator, Evolare, UK is obviously an important market for us. So we are interested in certifying there too. This is obviously going to go through our home regulator, EASA. And so, yes, there will be something forthcoming, but that's going to be dealt with through the regulators, to ensure validation. As far as I understand, the UK is leaning towards, in certain respects, towards EASA standards. I think they have adopted something that is similar to SC-VTOL. Actually, it is SC-VTOL because it was before they left the EU. And so, there are some rules that we can lean on that will be similar to our basis here. But yeah, it's going to be a process driven from EASA.
Sounds good. This morning, WISC spoke about autonomous eVTOLs. What are your views regarding certification for the same? What will the timeline for approvals look like? Autonomous.
That's a really hard one. The real answer is nobody knows. Our perspective is that we can bring a really great product to market that's able to deliver a service that people want at attractive prices with extraordinarily high levels of safety. With a pilot today, we don't need laws to change. We just need to go execute. So at the same time, we think to scale up and, as the market builds, certainly autonomy is going to make sense. Is it 10 years from now? Is it 15 years from now? Hard to say. Nobody knows, but I think it will happen in time.
I think we have to stop thinking of autonomy as a binary, autonomous, non-autonomous. It's a whole spectrum. These vehicles are going to have high degrees of automation on board from the earliest vehicles, and that level of automation will go up over time with a pilot on board. We've created a construct through Gamma with our members over years called Simplified Vehicle Operations, which basically looks at that spectrum. It's almost like a sliding graph of level of automation goes up, intensity or requirements for pilot training go down. So you go from fully manual aircraft on one end of the spectrum to fully automated on the other end, but there's a spectrum in between, and we need to have a regulatory system that allows different levels of automation and ensures safety through that spectrum.
Couldn't agree more with that, and I think that's reflective of, if you look at the pilot standards today that are embedded in the systems in terms of how many hours they have to get to certain qualification levels before we feel confident that they can fly safely in the system. And the reality is with more and more automation, you don't have to necessarily take the entire pilot out, but you can certainly look at whether that level of experience is necessary to safely operate, especially when you have that degree of automation. So I think this becomes an evolution, not a radical left or on or off type situation that Tom refers to.
You guys are going to love this next question. Fits perfectly in. 3 votes for this one. If 1,500 hours of fixed wing experience is required to get a 121 pilot position, how is 1,000 hours of powered lift going to help a pilot? Anybody?
Well, that wasn't entirely correct. So how's the 1,000 hours powered lift requirement? Let me back up. The same requirements exist today. They haven't changed them. They have what they've done in the SFAR is they've simply allowed credit for powered lift to contribute to the experience requirements that already exist today. So they've added to that. Now they've done a few additional things in terms of how they've accommodated some of the long distance flying requirements and instrument flying requirements, and there's a few other things that are part of that. But the fundamental standards of experience have not changed. They've just simply allowed powered lift to be a contributor to a pilot's experience time, just like a rotorcraft or any other aircraft type.
I would say it's also going to be difficult to build huge numbers of hours of these vehicles because the initial aircraft are going to have quite small ranges. It's not like you can do a 8-hour transatlantic flight in these things. So to try and build 1,500 hours in a vehicle that's got a range of between 50 to 300 nautical miles will be quite challenging. My personal view is we need to look at competency-based, making sure the pilots are trained for all the different possible scenarios, normal and unforeseen scenarios that can be planned for. And we focus on that. Arbitrary numbers, in my mind, aren't always the perfect thing. Sometimes they're a necessary fallback position, but we need to focus on the competency of the pilots to make sure they can train for those different circumstances.
It's true, and remember that our pilot training systems are not designed to be one aircraft only, all right? They are designed to give that pilot experience with the totality of the National Aerospace System, which in its current construct will require him to learn how to fly a fixed-wing aircraft out of a traditional runway. And there's actually that's a positive element to that. So I don't see anytime soon a scenario where a pilot, an ab initio pilot, learns how to fly one of the eVTOL aircraft, and that's the only thing he ever learns how to fly, even though he gets a type rating in it. For lots of multiple reasons, and the negatives of trying to look at it in that narrow view are pretty significant. So you really want that pilot to have that broader set of experience, but you don't want to complicate it so much that it takes forever to build up that time.
From an infrastructure standpoint, vertiports, fixed-based operators, is there a certification element there that we should be talking about?
So the FAA has published essentially a set of standards for vertiports, very similar to existing standards for heliports. In the US, those are not regulatory, meaning you don't have to comply. They're essentially guidelines. So I think it's going to depend on the specific operations that each manufacturer is targeting. So to give you an example, one of the routes that we've announced with United is taking passengers from existing heliports in Manhattan to Newark Airport. So you can think of a United customer who's going to go on some transatlantic flight, having that ability to kind of check in and save the 90-minute drive to Newark. So in that example, we're leveraging existing infrastructure, but say on the Newark Airport end, we'll obviously have to integrate with the existing operations there, both the physical on the ground as well as the ATC environment. I think over time, there's going to be more and more bespoke infrastructure built, but early days, leveraging what we have already, I think is the best path for the industry.
So in Europe, you do need to have approved landing sites and this is in most member states of the EU, where that can accommodate eVTOL. We do have EASA standards; those are non-binding. So again, there's no obligation for the member states to follow those, but they embrace actually these standards. It's the vertiport design standards, so-called, that were issued last year, because it helps member state regulators to understand how vertiports or landing sites that can accommodate eVTOL need to be designed. So it's actually quite helpful for them. But then when it comes to the actual landing site, you'll have to go through national and even regional in some countries regulators to run through approval procedures to basically change existing landing sites to be able to utilize them for your eVTOL. So it can be quite a complex process, even though it's existing infrastructure. Hopefully not everywhere, and hopefully not too difficult, but that's a process that we are working on with different member state regulators together with our infrastructure partners to really help them advance and understand what is actually needed.
I think the last thing that I would point out is that while a lot of the vertiport standards exist, the concept of operations of these eVTOL aircraft and these vertiports is much more concentrated than we've historically have seen from rotorcraft operation. So that's going to challenge the standards and the regulations, and the aircraft in themselves. Their actual performance characteristics are quite different than large bladed rotorcraft. So you have some other complications that are going to make this pretty interesting as we try to scale the vertiport operations up.
Plus, when you add in charging infrastructure, on-site maintenance, emergency procedures, it's going to be an interesting setup. But we also need to make sure we can allow these vehicles to operate in and out of existing heliports and airfields. So we have a whole network to build up over time, because we can't rely entirely on dedicated vertiports for these operations.
So basically, you guys are not going to be bored in the next little bit. Yeah. I hate to do this, but we've run out of time. Thank you so much, and thanks for the great questions. And there is a session on air traffic management tomorrow, I believe. So we kind of hit some of the certification and then the infrastructure, but missed the air part. But that is a great session tomorrow, I believe. So anyway, thank you to the panelists. Really appreciate it.